Hello there, and welcome to video number 182. This video is on trigonometry and the area of a triangle. Now, keywords are area, which is the space inside a 2D shape measured in squared units. Squared units are what you measure area in, and the segment is part of a circle that is created as the space inside the circle that's created by when a chord joins 2 points of the arc, which is part of the circle circumference together. Okay, now we'll look at that in question number 3. Now the formula that we use here is half AB sine C. So you will know how to work out the area of a triangle. It's half the base times the height. Alright, half the base times the perpendicular height. This is using trigonometry. This is a formula. This will always work. So we can use this to work out the area of a triangle. We do it the same method as the sine and cosine rules. So label the angles, big A, big B, big C. The sides, little a, little b, little c. Write out the formula, substitute, calculate. We might need to rearrange at some point if we're given the area, and we might need to employ the sine and cosine rules as well at some point. All right, we'll have to look at some of these questions and see if we need to do that. So the first question is very simple. We've got to find the area of the triangle, the first one, the blue one, and give our answer to one decimal place. So it's a good idea to label, or it's imperative really, that you label the angle that you're given the big C. Okay, therefore that's our little c. All right, then we can say that that's A, and that's little a, that's big B, and little b. Right, now it doesn't matter what ones are what, but it does matter that big C is here next to that angle. So substitute in, I'm going to do it over here for a little bit more space. Substitute into half AB sine C. Okay, so half multiplied by A, which is 22, multiplied by B, which is 28, multiplied by sine of the angle, which is 18. That is the calculation that gets us the area of the triangle. So we could write down area equals. Okay, let's type that into the calculator. I'm just going to bring the calculator in. Hold on a sec. There we go. And yeah, just type it in. So half multiplied by 22, multiplied by 28, multiplied by sine of 18. Easy stuff, 95.17, so to one decimal place, 95.2. The area equals 95.2, and that was meters, so this area will be in meters squared. There you go. So that was for the first question, that working over there. I'm going to get rid of that because it's in the way of what I need, or the space I need for the next question. Now the next question is a little bit more complicated because we've got 3 sides. We haven't got an angle. We need an angle to use in this. We have to have one. So the way we're going to get that angle is we're going to employ the cosine rule to find angles. And the cosine rule to find angles, hopefully you'll remember it if you've done your practice on it. And if you don't know what that is, then go and watch the video on it, which is the previous one to this one, I think. So yes, the cosine rule for finding angles is cos A equals b squared plus c squared minus a squared over 2bc. Okay, if we substitute our numbers into that, the correct numbers into that, we'll inverse, and then we'll find this angle A. So we're going to call that A at the moment. That's then little a, then this can be B, and little b, and this can be C, and little c. So let's sub in cos A equals b squared, so that's going to be 9 squared plus 6 squared minus 11 squared over 2 times 9 times 6. If we type that in, we're going to get cos A equals, so let's get our fraction button up, 9 squared 6 squared minus the 11 squared. Nope, that's a 1. No, that's all gone wrong there. Go back in. Okay, and then 2 times 9 times 6. That's all good. Minus 1/27. Okay, so that's minus 1 over 27. Right, to get A, this isn't our answer by the way, this is just this angle at the moment. To get A, we need to inverse the cos. So shift cos answer. Alright, that's all you got to do. So A equals cos to the minus 1. Answer A equals 92.12, etc. Right? So that's great. Let's write that in there, 92.12 degrees. And then we're going to use that in our calculation of half AB sine C. Okay, so I'm going to get rid of all of that, even the labelling of the sides of the triangle, because we can relabel the sides of the triangle now. Alright, that's going to get you a few marks anyway, just doing that, getting the angle, and then you get another few marks for getting the area. So this could be 6 marks in total on exam paper, but the next 3 is really easy. So we'll get rid of that, like that. And then, like I said, label this C. So that's your C, and therefore this then becomes little c. Right? All of these are interchangeable always. So A and then B, doesn't matter which one is which. So you just go in half AB sine C. Okay, that's why we make it C. So our area equals half multiplied by A, which is 9, multiplied by 6, because that's the B, and that does look like a B anyway, doesn't it? 6, multiplied by sine of the answer. Alright, let's just type that in and see what we get on the calculator. So 1 over 2 sine of the answer. Alright, because I didn't round anything. Nice and accurate then. So there's our area. Area equals 27, right? Units squared, centimetres squared. Rounding to 1 decimal place. 27.0 centimetres squared. There you go. That will do. That's absolutely fine. I hope that all makes sense. That was a lot trickier than the first question, right? You could be lucky and get that. That's really simple, the first one. The next one, a little bit trickier. Now, question number 2 asks us to find x, which is the angle. We've got to give our answer to 3 significant figures if we can, and the area is 14 centimetres. So this is just a case of knowing that the area equals half AB sine C. And then you can substitute that 14 in there where it says area equals half multiplied by A and B and sine C. So that's our C, remember, that's our angle, right? So that's our little c. Let's call that one A, therefore that's little a. Let's call that one B, that's little b, right? So we've got those numbers which you can put in. So A is going to be 9 times by 9 times by B, which is 7 times by sine of x. Right, that's the thing we're looking for. Now let's get rid of the like all of that. That's all over 2. You could write that as all over 2. So get rid of the all over 2 by multiplying both sides by 2. So that's going to give us 28 equals 9 times 7 times by sine of x. So 9 times 7 is 63 sine x. I'm just doing that without the calculator at the moment because you can, like, there's no reason not to. Then we're going to divide by 63, so that's going to be 28 over 63 is equal to sine of x. And then to get rid of the sign in front of the x, and that's going to give us the angle, we inverse it. So all of that I did without a calculator. Like I said, could, doesn't really matter, as long as you're sure of yourself. But then what we need is the 28 divided by the 63. Just press equals. You get simplifies the fraction to 4/9, and then you go shift, get your sign up for your sine to the minus 1, and put your answer in. Okay, I'll write that down in fact before I get that. So that's going to be sine to the minus 1 of 4/9, wasn't it? Is equal to x. All right, that's going to get us our answer. 26.38. X equals that. So x 26.38, 26.4 degrees to 3 significant figures. All right, there you go. And if you try that in your forward, so if you want to do it forwards, right, what we'll get is something very, very close to the area of 14. All right, so if you were putting that into the formula, as it was half AB sine C, half times by 9 times by 9 times by 6 times by sine of, let's use the rounded version, 26.4. Alright, you're going to get something very close to 14, which is not really that close. It's a little bit off, isn't it? So, oh, my eye is really itchy, sorry. Yeah, I'm not sure why that's so far off. How did I make a mistake there? Yes, because I put 6 in instead of 7. Yeah, let's try that. That'll work then. And there you go, 14.006000 there. Yeah? Okay, sorry, a bit tired. And, yeah. But I got there. So, next. Question number 3. A, we've got to calculate the area of the segment. Now the segment is the blue bit of this sector. This is what we'd call this part of a circle, we'd call it a sector. And to work out the area of a sector, the whole thing, which is what we do need to know how to do, it's just the angle at the centre out of 360 and then use the formula for the area of a circle. So that's 135 out of 360 multiplied by pi multiplied by the radius squared. The radius is 5.6 because that's the centre of the circle, what would be to the edge of the circle. So that's 5.6 squared. And that's going to be the area, okay, of the sector. Okay, I probably should write that. That's the sector, not the segment. But let's just see what that is. So area, let's put sector there. Area sector equals, type it in, find out. 135 out of 360 multiplied by pi multiplied by 5.6 squared. That's 294 25ths of pi. I'm going to write it as that, 294 25ths of pi, because that's the most accurate at the moment that we can get as an answer, and that's what we'll use because we're not finished. Now, this area of this triangle here, the white triangle, can be worked out and then taken away from the area of the sector to leave us with the area of the segment. Alright, hopefully that's what you were thinking you needed to do. Now remember, if that's the radius, then that's also the radius, and that's also 5.6 centimeters. And what we have got to do is work out the area using half AB sine C. So half area of the triangle equals half multiplied by A, which is 5.6, multiplied by B, which is 5.6, multiplied by sine of 135. Okay, and if we type that into our calculator, as ever, half times by 5.6 multiplied by sine of 135. That's the area of the triangle. Alright, so the area of the triangle equals 11.087 centimeters squared, and we can then type in the 294 pi, 294 25ths of pi, and that's the area of the whole sector, and then minus the last answer that we had on the screen. Okay, so that's the area of the segment. $25.85, and let's just do 3 significant figures again. So 25.9. There you go. That's how you work out the area of a segment. Work out the area of the sector, work out the area of the triangle, take the area of the triangle away, and you've got the area of the segment. Okay, it's just like a shaded area question. Now, question B in this, it asks to prove that the area of any triangle is given by the formula half AB sine C. So it's a useful thing to know this, and it revolves around the world of trigonometry, funnily enough, because that's what we're doing and what we're using. But right-angled triangle trigonometry. So if I drew a triangle that is clearly not right-angled, okay, and then labelled it A, B and C. There's A, B, C, right? We know that's little c, we know that's little a, and we know that's little b, okay? And what we are looking for, or what we know, is the formula for a triangle is half the base times by the height. So if we call this the height, the perpendicular height, let's call it h, okay? We can use that now in our proof, all right? So let's just write out the formula, half AB sine C. Okay, and then what we'll do is we'll say half this base, so half of A. We're starting it off okay, aren't we? That's fine, right? That's normal, half the base, half of A, right? But we need to get this B sine C bit, okay? So if we were to draw a right-angled triangle, this right-angled triangle, in fact, okay, so from this point here, this hasn't got a name, this point, right? Call it point P or something if you wanted to. PAC, yeah? We could draw that triangle there, right? And there's our C, and there's our H, and for height, and there's our point A, and there's our little B over there, right? And we don't know what that is. We can't really label that anything because it's part of the base, right? We don't know how much of the base it is. Depends on the triangle. Anyway, what you do with this is right angle triangle trigonometry is you label the sides as you normally would, right? So this is the angle that we've got. This is sine C. So we've got opposite sine C, and we've got B. We've got the hypotenuse. Okay. So what you use is SOH, the formula triangle here for SOHCAHTOA, the SOH bit. Right, and we put in sine C. So sine C is equal to the opposite over the hypotenuse. And the opposite is this letter H, and the hypotenuse is this letter B. Alright, and then what we can do with this is actually just rearrange it very simply by multiplying both sides by B. So what we end up with is B sine C equals H. Okay, and what we can do is substitute that in to our formula. Okay, so half a B sine C is what we end up with. Okay, that bit there gets put in, and that would be just half the base times by the height. Yeah, so 8, oh, we probably should write that as well. Half the base times the height is how you would normally work out the area of a triangle, and that's our proof, right? We've shown that we can get sine C equals H over B, and then simply B sine C equals H. All right, that might seem a little bit confusing, a little bit complicated, but show this, and this is all you have to do every single time. Remember those steps, and you'll be able to prove that any triangle can be worked out by that given formula. All right. Again, my hand is starting to hurt. It's taking its toll on me, these videos. Hope you're watching them. I hope you're learning from them. I hope you will continue to do so for a long time. Thank you so much for watching. Take care of yourselves. Look after one another. Good night.